Okay, lecture 11 is going to be understanding piecewise functions. This is a pretty difficult lesson for us, but if you guys have checked your calendar, we are also going to be reviewing piecewise functions next time. So if you guys have questions while you're working through this, make sure you write them down so that I can come back and answer those for you guys next class. So we're going to do two things here. We're going to start out by graphing the piecewise functions, and then we're also going to talk about evaluating piecewise functions. So starting off, we'll do the graphing. So what is a piecewise function? Well, it's just a function that is comprised of two different functions, and they're graphed on the same graph. The difference is it has to deal with their domain. So your domain is going to shift as far as what function is where. So if we kind of break down this top one here, I have f of x equals x if x is less than 0. So where my functions have values of less than 0, which would be in this section over here. This is where my x values are less than 0. Okay, the function f of x equals x is going to be present, which f of x equals x, remember f of x is just y, so it's just the line y equals x. Okay, and that line is shown right here. Y-intercept at 0, it's got a positive 1 slope, up 1 to the right 1, up 1 to the right 1. Okay. The bottom part of this says that f of x equals negative x plus 2 if x is greater than or equal to 0. Okay? So that's saying where all of my x values are greater than or equal to 0, meaning on this side of the graph, that's where my x values are greater than or equal to 0. Okay? In that section, I'm going to have f of x equals negative x plus 2. So again, that's really just saying y equals negative x plus 2. So it's got a y-intercept at 2, slope of negative 1. So I'm going to go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. So this line is shown right here. Okay? So depending on what part of the graph you're looking at, it changes what function you look at. The only other thing I want to talk about is I've got a greater than or equal to sign. That's why this dot is closed here. Versus on this one, I have just a less than sign, which is why this has an open dot here. Okay? So, pause if you need to take some time to ask some questions amongst yourself, and we're going to get ready to start graphing. First one that we have is f of x equals x squared if x is greater than or equal to 1, or it equals x plus 1 if x is less than 1. Okay, what I would suggest for you guys to do, okay, first thing, graph both of these functions. Okay, so my two functions are f of x equals x squared. Okay, that's a parent function. That's my parabola. So it's going to be 0, 0, 1, 1, 2, 4, negative 1, negative 1, negative 2, 4. Okay, and then I need to graph my bottom one, which is just f of x equals x plus 1. Okay, that's really y equals x plus 1. So it's got a y-intercept at 1, and its slope is 1. So y-intercept here, slope of 1, I'm going to go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, and so on. Okay, and it's going to be this line that comes down right through here. Sorry, that's not very straight. Okay, so that is both of our two functions. So we put both of the functions on the graph. Then we need to identify what our split point is. And the split point is going to be where does it change from one function to the other. So on this graph here, our split point is a 1. And again, what that means is on the left side of the 1, you're going to have one function. And on the right side of the 1, you're going to have another function. Okay? So we're going to come to the graph here. And I'm going to just draw a dashed line. Okay, because on this side of the dashed line, there's going to be a function. And then on this side of the dashed line, there's going to be a different function. Okay, so what function needs to go on the left side? Well, the left side has values like 0, negative 3, negative 4, negative 5, negative 6. Those are all values that are less than 1. Which of these says that we need values less than 1? That'd be this one here. So on the left side, I should have my line y equals x plus 1. Okay, on the right side, I've got numbers like 3, 4, 5, 6. Those are all numbers that are greater than 1, which is a part of my top function. Okay, so on the right side, I should have my parabola, y equals x squared. Okay, so on the left side of the function, I should see my red function. On the right side, I should see my blue function. So left side red function, I'm going to erase this part of my parabola here. Okay, I'll add back in my red line. Then on the right side of the function over here, the only thing I should have on the right side is my blue function, my parabola. So I'm going to erase my line over here. Okay, and then I'll draw back in. Okay, so start out drawing both parent functions first. Okay, figure out where your split point is, and then you decide what function needs to be on which side of the split point. Okay, the only other step you have to do at this point. Okay, I need to look back at these. I've got a greater than or equal to. I have just a less than. Okay, so my blue function, I'm including this point. But in my red function, whoops, went too far. In my red function, I need an open circle because it's just a less than. Okay, so if I erase all this other extra stuff, that's my piecewise function. It's got a piece of a parabola over here, and then it's got the line on this side. Okay, now I'm going to have you guys turn in your notes, so you're going to have to work with me and find this slide. Whoops. Click through all this stuff, sorry. Okay, I want you guys to turn and find this slide here. Okay, it's one of your practice ones. It's towards the back a little bit. It's not too far back though. Pause this until you find this slide. Okay, all right. So we're going to go through. We're going to practice this one again. Okay, I got two functions. I've got f of x equals 2x minus 5. Here, I'll even erase that because really we don't need to know that part yet. I need to graph that function first. So y-intercept is at -5. Slope is at 2. So I'm going to go up 2 to the right 1, 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 up 2 to the right 1. Okay, there's my line. And some of you guys may just want to put the points down and wait till you figure out your split point, so then you aren't having to erase, and that's okay to do. Okay, my other function is f of x equals x, or the cubed root of x. Sorry. F of x equals, excuse me, f of x equals the cubed root of x. So 0, 0, 1, 1, 8, 2, -1, -1, -8, -2. Okay, so there's my cubed root function. All right, now, where is our split point? Okay, this is where we need to decide where our split point is. It's at 1 again. Okay, so I'm going to put my dashed line at 1. Okay, again, I'm going to ask myself, what function do I need on the left side? What function do I need on the right side? Well, if we look, okay, the top one is x greater than 1. Greater than 1. I've got numbers like 6, 5, 4 on the right side. Those are all numbers that are greater than 1. So that means that on the right, I need my red function, my 2x minus 5. Okay? If I look at my bottom function here, it wants values where they're less than 1. So where are our numbers that are less than 1? -6, -5, -4. Those are all numbers that are less than 1. They're on the left side. Okay? So this is going to be our cubed root of x. Okay? So right side, I only want the red function. I've got to erase my blue function. Okay? Right side, or sorry, I said that wrong. Left side over here. Okay, our left side, we only want the blue function. So blue function's good. I need to erase my red function part. Okay? Red's on the right, blue's on the left. Last thing I need to do, check my signs. My blue function is greater than or equal to, so closed. My red function is just a greater than, so it's going to be opened. Okay? Sorry. Any questions on that? Okay. again, we may need to skip here. I need you guys to find this slide here. Yep. So our lesson practice slide. Okay, I want you guys, before you watch this video, I want you guys to go ahead, try this on your own first. So pause the video right now, try this on your own, see if you guys can get it figured out. Okay, so these are what your answers should look like. Okay, up top here, I have my red absolute value function. Okay, remember your absolute value is your V. Okay, so the only thing that was left was from -1 on. So it's just this angle here. Our split point is at -1. That'd be right here. Okay, down that line. Okay, split point's at -1. On the left side, I wanted my absolute value. On the right side, I wanted the line y equals 2x minus 3. It's got a y-intercept of -3, which you guys can see down here. And then it's got a slope of 2, up 1, or up 2 to the right 1. Okay. It has the closed dot with the blue. I could probably make that a little bit bigger. Okay. Open on the absolute value. Okay. On the other side over here, this one was a lot more complex. There's 3 of them. We have 2 split points. I got a split point at -2, and I got a split point at 2. Okay. Top line here, -x minus 4. That's the one that's in the red. So that's everything to the left of -2. Middle function, -x squared. That's my parabola. Negative's on the outside, though. So negative on the outside makes it flip vertically. So my parabola flipped vertically. And that one is between -2 and 2. So here in between -2 and 2, that's the only spot that our parabola is. And then on the right side, this x minus 4 here, okay, that's again a line, and that's to the right of the 2. Notice that the green function here, my bottom one, okay, that's got our closed circle. The parabola on the right side has an open. Okay, parabola on the left side has a closed. And then our top function here, the red one, it's got an open circle as well. Okay, so there's our lesson practice problems. Go ahead after you do this. Now we're going to talk about evaluating these piecewise functions in the second video.